Hello. Sometimes chat AI makes stupid mistakes. It will not be able to count the number of letters in strawberry or make calculating errors, or it will just make stuff up. In this session, we're going to look at why it does that and what methods are used to prevent that kind of thing happening. So just a refresher, in a previous session, I talked about how AIs are trained on tokens, and when you put a question into AI, it's converted to tokens, tokens being essentially just numbers, and the tokens themselves being based on the frequency of occurrence of strings of characters in the huge amount of data that AI is trained on. So in this case, each word has been changed into a token, but for longer and more obscure words, it will be broken into multiple tokens, and even numbers. If I put a string of numbers here, you can see that that long number has been converted into 3 tokens. So whereas we see 234, the large language model would see 11,727. So text is converted to tokens, and tokens is what the large language model deals with. Also, a little refresher. So when you put text into a large language model, it responds with text based on probabilities. And each time it's all fed back in to the large language model as it keeps on increasing. So it's creating the probabilities on the basis of all of the text that's gone before. So in this case, we've got today I am going, that's been converted into the tokens, the numbers. That goes into the neural network. The neural network has been trained on enormous amounts of textual data. The neural network responds with essentially probabilities for the next token, and then it uses that as a weighting to actually choose one. And in this case, it's chosen 2. Today I am going to, but it could have chosen home or whatever. The what it returns is just a list of probabilities, but it doesn't necessarily pick the most probable next token. It uses the what is returned as the weighting for what it chooses. So the first thing I want to talk about is temperature, because I think this allows you to understand a little bit better how large language models work. So let's just do some demos. These are live demos, so I don't know exactly what it's going to return. We're using the model DeepSeek v3 here. Write a poem about a cat. Whiskers in the Moonlight. There you go. It's come up with a poem, and by default, the large language models have lots of variables set, one of which is the temperature, and they have the most sensible default set. So in this case, temperature has been set at 0.8. But let's try again and make that really, really high. So write a poem about a cat, and we take the temperature, and rather than 0.8, we'll put it to 1.6. And now you'll see that it started in a very similar way to before, but as it goes on, it starts to use more and more unusual language, and sometimes it's just kind of making up words, so that'll be a combination of two tokens that wouldn't commonly occur together. And what temperature is basically how random it is in choosing the next token. So the higher it goes, the more random it gets. And because we have this process of it feeding back what it said before uh, to work out what the next token is, as it goes on, if you have a high temperature, then what gets fed in becomes more and more odd, because it's choosing tokens on the basis of kind of odd things it's chosen before, and it just gets more and more weird until it's you can see it's just nonsense bunches of characters by the end. So you can also go the other way and put temperature to 0, and then it will produce almost identical poems each time. Not necessarily identical for complicated reasons, but if you put it to 0, you've got a high probability of getting the same thing each time. So let's ask that question, how many R's in strawberry? This was a question that was asked of GTP4, which is the model we're using here, which was supposed to be an intelligent model, and it got the answer wrong. There are 2 R's in strawberry, of course there's 3. And this made a lot of news earlier in the year. So if we now look at GTP5, the current model, it'll get that answer right. And how does it do that? It does thinking. So what is thinking in this case? So how many R's in strawberry? These are all live demos, but it should answer the right way. You can see it's, rather than just responding as GTP4 does, now it's saying thinking. And it's thought for 9 seconds and has returned the right answer, 3. If we just click here, we can see what it was thinking. And you can see this very long text where it goes through and spells out the individual letters of strawberry, counts them, it then double checks itself, and it's a lot of more checking of itself, checking that it's understood the question. So an awful lot of thinking for a very simple question. And what is happening here is that, as I've said before, the text that it outputs is input again as part of the process. And as it reasons like this, it is actually increasing the probability of getting the answer right. So it goes through this very convoluted process of thinking. And what that's doing is increasing the probability that it will write the correct answer at the end. So how does it actually know when to think and what to think? There's something that, as a user of things like ChatGTP or Claude, you don't see, and that's called the system prompt. And the system prompt is a very long piece of text that is sent to the model, the large language model, along with whatever you've put in. And it goes into great detail about how the model should respond. One fun thing we can look at here is if we have a look for Let It Go. Look, Let It Go is the song from Frozen, of course, copyright Disney. And this particular system prompt is from Claude. And it gives an example here of how to respond. I've lost my bit home. It gives examples of how to respond to particular questions. And with this one, with Let It Go, the question is, tell me the first verse of Let It Go. And the response it suggests is basically not to respond with the first verse of Let It Go. As I've said, it's copyright Disney. And then it's got the rationale for that response. Claude cannot reproduce song lyrics or regurgitate material from the web. And if you look at this system prompt, it's absolutely huge and it's got all kinds of things in, but it basically tells the large language model how to respond, and it tries to avoid it responding, saying stupid things, or in this case, saying things that it shouldn't say because of legal reasons. It's all in the system prompt. Let's look at another case of where models often get things wrong. In this case, I'm using Gemma, which is this is actually a model that's running on my computer here. It's a very clever model. It's quite small, so it'll run locally. And I'm asking it this this mathematics question, a big division. The correct answer to this is 20. Let's see what Gemma comes up with. So it's restating the problem, and then it's trying very simple ways. It's actually got it right. It says the answer is 20, so that's great. When I've tested it before, it's got it wrong every single time. But as I've said, this is a probabilistic process, and so in that case, it got it right. Let's try it again. So in this case, it's responding in a very, very different way. And you can see it's actually come up with a different answer this time. So one simple rule of using large language models is that the way that they work is probabilistic. It's random. So if you want a answer where there is only one right answer, a large language model isn't, the right tool to use, really. But you've probably used newer models and you've seen that they've responded correctly to that kind of question. So how do they do that? Let's have a look at the system prompt again. And this time we'll have a look for the word calculate. And you can see here in the system prompt, it says, any calculations involving numbers with up to 5 digits are within your capabilities and do not require the analysis tool. Calculations with 6-digit input numbers necessitate the using the analysis tool. So the large language model actually has at its disposal this analysis tool which can do maths, and that tool is just a standard computer program. It's not a AI thing, because of course standard computer programs do actually do maths pretty well. And so within the system prompt, there's a long explanation about how to use that tool. And large language models have a whole variety of different tools available to them now to help them answer questions. And this all goes on behind the scenes. So just as you don't see the system prompt, you don't necessarily know it's using the tools. Another issue that large language models have, people call hallucinations. It's basically making things up. One of the problems with the way that large language models generate responses is that it doesn't really know when it doesn't know something. It will always respond to a question, and so the way it responds will be probabilistic, and large language models were made to be really good at language, and they are really, really good at it. And that means that they're very, very good at just making stuff up. So this is great if it works. Again, I'm using Gemma. I'm asking a question about a town that I've just made up, Hampton, which kind of sounds a little bit like it might be a little village or something in England. where is Bodegohampton? So let's see how it responds. And I really like these things because it's just so good at making this stuff up, and it's often very creative and imaginative. It says Bodegohampton is a tiny hamlet in East Sussex, England. It's located near the small village of Heathfield and is part of the Rother Valley. And it's got a link, well, to Google Maps, telling you to search for Bodegohampton. Let's do it again and see what it comes up with next time. Asking the same model. And this time it's saying it's in North Norfolk, and it's located near in the Blickling estate, part of a National Trust property. And it's actually got a link to a web page about Bodegohampton on the National Trust website. So if we click on that, we'll see that it's just a hallucination. We get a 404 error because that doesn't exist, right? That page doesn't exist, but it's a very convincing response. And you can go further. You can do something like, who was James of Bodegohampton? And it'll make up something else probably. James of Bodegohampton has given birth and death dates with a remarkable and somewhat enigmatic figure in Norfolk history. Like I say, it's just very entertaining often what it comes up with, and very convincing. So it's giving all this really interesting information about the character that I've just made up. So you have to be extremely careful with the output of large language models, especially if you're asking about more obscure things. Some people have, for example, lawyers have used this for researching cases and have got in a lot of trouble thinking that they were looking at real cases when it was just made up in the same way that this one has been. So let's ask the same question of GTP5, which is a newer model and so can handle better this kind of situation. And you'll notice this time it's taking a while to respond, and now it's thinking. Taking a long time to respond. There you go. I can't find any real world place called Bodegohampton in Common Maps or Gazetteers. So one of the ways that they have stopped the hallucinations is basically by searching for searching the web when you ask a question like this. So if it searches the web behind the scenes and it doesn't find relevant web pages, then it knows that it's not something that's real. It also will do the thinking process, where, as I've said, this thinking process of actually writing out its thoughts increases the probability of it giving a correct answer. But yeah, increasingly it will do searches behind the scenes, very quick ones that you don't necessarily know it's doing, and it will use that as the basis of responding. So just to summarize then, we've seen these ways that are used to improve the way that large language models respond. Thinking, the system prompt, which tells it how to interpret the user's input. And we've looked at two tools, an analysis tool for responding to maths type questions, and the search tool. So one of the things that you have to think about with this is that actually the large language model is still kind of really just as dumb as before. It can still respond in that dumb way, but it's got this kind of layer of tools and mechanisms on top of it to prevent it saying stupid things. There are other techniques that are being used to try and prevent hallucinations and things like that, but the base large language model, they're not really intelligent. They're not. They don't think in the way that we do. They have kind of these workarounds to make the response um, seem more intelligent than it actually is the process. There isn't our kind of intelligence behind that. That may change, but you've always got to keep this in mind when you're prompting large language models.